Okay, so what we're going to do in this video is we're actually going to run through the same data that we just saw in the PowerPoint, and we're going to use JASP to run the correlated groups t-test. So I've entered the data already into Excel, uploaded it into JASP, and I'm not going to show you how to do that because I assume you know how to do that at this point. But basically you're just entering in the data into Excel. The first row will always be your variables. So I have 3 variables here: subject, pretest, and post-test. And then the data come underneath that in the column. So the first row represents the data for subject 1 on the pretest score, and then the post-test score. So and just remember, in Excel you need to save that file as a CSV file for JASP to read it. So now we're going to go to the t-test itself, and you'll notice there's nothing here that says correlated groups t-test. A lot of textbooks and software will just say paired samples or dependent samples t-test instead. So just be aware of the difference in the terminology. So we're going to click on paired samples t-test. Now, up comes our screen, and we want to select, before we start moving the variables over, let's go through our selections for how we want to run the test. And we're going to select a student t-test, so that's correct. We know that we're running a 2-tailed test from the prior videos, so we're going to select that the alternative hypothesis should be measure 1 does not equal measure 2. So that's equivalent to the correct specification of the alternative hypothesis. Let's run our normality check because we want to check our assumptions, and one of those is normality. Okay, and then we move to our additional statistics, and we'll click off location parameter and a confidence interval. Okay, and that's just going to tell us how confident we are in a population of the true mean difference from sample 1 to sample 2, and then effect size and confidence interval, and that's going to give us an interval within which we're 95% confident that the true Cohen's d effect size in the population is located. And then we'll click on descriptives. I'm going to skip descriptive plots for now, and we'll go up here and now just select our variables. Now we're going to be comparing pretest scores to post-test scores, and we'll keep it just the way it was in the handwork. So we're going to click pretest first, and then we move it over. And you'll notice that there's this sort of grid shows up. So one of the variables is already over there, and now we need to do the other one, which is post-test. So the ordering here is actually important because what's going to happen, pretest is now considered x sub 1. Post-test is now considered x sub 2. So when the d score is calculated, post-test will be subtracted from pretest. Now, that's going to put the sign in a particular direction. But I can easily change that, and I'll show you that in a moment, and you'll see the effect on the printout. Okay, so we're going to go down here. We're going to skip this top part. Just go right down to the bottom, and we'll see our descriptives. You'll notice that our n equals 7 for both groups. There's a mean of 28 in the pretest scores and a mean of 31.857 in the post-test scores. Standard deviations are reported, and then the standard errors for the pretest and the post-test. Okay, so nothing really to do there, just good to sort of inspect, because we notice right away that the scores on average did go up from the pretest to the post-test. Now, how much did they go up? Well, they went up on average 3.857 points, and if you recall from the handwork, we had calculated the mean D score as being 3.86, negative 3.86, meaning that the pretest scores were on average 3.86 points lower than the post-test scores. So that tells us that the data were entered correctly here. Everything's checking out so far. We go to our assumption check, and this is just a check of the normality of the underlying distributions that are used. We want this assumption check to yield a p-value that is greater than 0.05. Okay, and that would be helpful for us. We would like to meet the assumption of normality. And the good news is that's what we got right here. You know, that the p-value for the statistic is greater than 0.05, so there's no evidence that our underlying raw score distributions here are in fact non-normally distributed. So that's good news. Then we go up to the t-test itself, And the calculation from JASP came out to negative 5.229. Of course, if you recall, from our actual hand calculations, we had negative 5.23. So our hand calculations correspond with what JASP is coming up with. It all checks out. That's a good habit to get into, is to check your handwork against JASP. Degrees of freedom is 6. The probability, the p-value, the likelihood that the result we're seeing in the t-ratio, the negative 5.229, is due to sampling error is really low, only 2 in 1,000, and that's less than 0.05. So we will reject the null hypothesis. You'll notice here that the mean difference is then reported, right? And it's negative 3.857. And if you go back to what we did by our handwork, our mean difference was negative 3.86. Okay, so that checks out as well. And then the standard error of the difference was computed by JASP as 0.738. And if you go to our calculations, we had it at 0.74, which is also correct. So everything's looking good so far. Now, the next column says 95% CI for the mean difference. Well, the mean difference is negative 3.857. Okay, so what this is telling you is that in the population, okay, we are 95% confident that the mean difference between pretest and post-test scores is somewhere between negative 5.662 and negative 2.052. So there's a range there within which we think, or which we believe and are 95% confident that the actual population mean difference will occur. So we observe in the sample a mean difference of negative 3.857. In the population, we're 95% confidence that it's somewhere between these upper and lower boundaries. And then the same thing is computed for Cohen's d. You know, Cohen's d simply reflects the effect size in standard deviation units. So the way you interpret Cohen's d is to say, okay, well, the mean for the pretest sample is 1.976 standard deviations less than the mean for the post-test sample. Now, there's a confidence interval for that that's calculated as well, because the Cohen's d that's reported here, negative 1.976, is for the sample. So in the population, we're 95% confident that Cohen's d actually would be located somewhere between the lower and upper boundary that's reported here, negative 3.272 and negative 0.637. Okay, so that's our measure of effect size. And remember, Cohen's d is always in standard deviation units. Okay, the only other thing that I wanted to show you here, so we've walked through pretty much the entire interpretation of the output. The only other thing I want to show you is how you enter in those variables to begin with does make a difference on the sign for the t-ratio. So I'm going to go back up here and I'm going to remove post-test or remove pre-test, get rid of all the output. And now what I'm going to do is I'm going to put post-test in first and then the pre-test. And you'll see that the t-ratio, the value doesn't change, but the sign did, right? It was negative 5.229 beforehand. Now it's positive 5.229. So the order matters because of the way the subtraction is done. And this output right here, especially for designs which are looking for changes or increases in scores over time, it may make more sense to enter in things like this, enter variables in like this, because you're expecting the scores to improve over time, right? So it's sort of odd to see a negative t-ratio. It's fine to do it that way. You just have to take into account that the negative value simply reflects that the first variable, the pretest in this case, has a mean score that's lower than the second variable. Okay, so you can order it however you want to order it. Just keep in mind that the interpretation needs to be correct of that sign, and you can always double check simply by looking at the descriptives, right? Because you'll see the means there. The means are going to be reported, so you'll know what direction they're going in. Okay, so the order just affects the sign. And that's pretty much how to run it within JASP. So pretty easy, not a huge amount of output, to look at, but just make sure you understand what you're looking at.